All right, number 5. Which of the following equations is even and which ones are odd? All right, we learned something about this. It has to do with this. If you have a polynomial function, if every term has an odd power, it's going to be odd. If every term has an even power, it will be even. So D automatically is going to be even because there's only 2 terms and both terms are even powers. This term will automatically be odd. It's automatically odd because each power is odd. Now, these two should be neither, but we can check out real quick. Now, remember the rules. For something to be even, that means if you have f of x, that will also equal f of negative x. Like they're not different from one another. What that means is this, graphically speaking. Here, this is saying x is positive, and basically the y is positive. I'm just saying this x is positive, so you have something over here, and the y is also positive. So let's go up here. So you have a point over here. This is saying over here you have a negative x, so now I have a negative x over here, and a positive y. The y is positive. Well, that would be a point over here. This is even because it reflects on the y-axis. It's like a face. It's reflecting even. So that's why this is even here. That's the rule for even. Now the rule for odd, if you remember, is that f of negative x is equal to negative f of x this way. So basically, as graphically speaking, what does that mean? That means that here I have a positive y and a negative x. That means left and up. If I go left and up, I have a point there. It's the same thing as a negative y with a positive x. So a negative y with a positive x, something over here. Odd means it reflects across the origin. That would be odd. These here are odd. Okay, so now when it comes to this, if I plug in a negative x, we can solve to figure out what's going to happen to the rest. So if I want to find out what is f of negative x on c, or let me do b first. So I would say, what is f of negative x? What I do is I replace the x's with negative x. Now, I can't simplify that any further. Is that the same? Are these two things the same? Like this. This is saying that you plug in the negative x, your y stays the same. The whole equation stays the same. So I plugged in my negative x. Does the equation stay the same? No. So this is not even because the equations aren't the same. If you're going, well, wait a minute, go up here or show me on one that's even, what would happen is you would plug in the negative x, f of negative x, that's ugly, let me write that again, would equal negative x to the 4th power minus 3 times negative x squared. We can simplify this. Negative x times negative x times negative x times negative x. That's 4 negatives becomes x to the 4th, 2 negatives becomes positive x. That's that. And guess what that was equal to? This is the same thing as that. These two things are the same, i.e., they're even. So over here, it's not even because these two things are not the same. And you can't simplify that. Well, for odd, they would have to be the opposite. Are these the opposite of each other? No, they're not opposite either. So it's not odd. This is neither. Okay? So this one's just neither. It's neither even nor odd. And the same thing here. If you plug in a negative, it will not equal the same thing, nor will it be the opposite. A negative would need to be over here on the outside for it to be opposite. So this one's also neither even nor odd. If you're wondering about the odd, plug in a negative here, and you'll see that everything switches signs. And so it would be opposite of one another.